One-sided limits means I'm coming only from one side. That means I'm either dealing with Howard or I'm dealing with Harriet. I'm not dealing with both. And if I'm coming from the left, that was Howard, then I'm going to have a little minus sign that tells me I'm coming from the left. So that says that is a limit as x approaches a, the minus sign is from the left of f of x equals some L. And then here's the guy that says instead the limit as x approaches a, and because that's a plus sign, that's going to be from the right. So that's Harriet by herself or Howard by himself. The limit as x approaches a is Howard and Harriet together. So they're either dealing it with alone or they're dealing together. So one-sided limits is together. What do you need one-sided limits for? Vertical asymptotes. Because it's x approaching a. That's the numerical value. Vertical asymptotes. We generally look at one-sided limits when we either have a piecewise function or we're having, so piecewise functions, we're going to see a picture of that, or we're looking at vertical asymptotes. And we can make it as easy or as hard as we like, to be honest with you. Now, for the limit, and this is what's important, and that's both Howard and Harriet together, and this should make sense. For the limit as x approaches a to be equal to L, then the limit as x approaches a from the left, Howard, the limit as x approaches a from the right, Harriet, they have to be the same. In other words, Howard and Harriet have to meet. If they don't meet, then you don't have a limit. That's your jump discontinuity, or your jump where Harriet ends up being up here and Howard ends up being down there. So in order for the limit to exist, they have to meet. The limit from the left can exist, the limit to the right can exist, but for the limit to exist at that point, it has to, Howard and Harriet have to meet. So if I look at the first picture, and it says find the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right, and the limit as x approaches 2, period. Well, if I look at the limit as x approaches 2 from the left of that function, that's Howard. So he's coming in, la 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 la, la 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 la, watching the flowers and the birds, maybe looking for a morsel of food, and then he ends up right there. And where's he going to end up? 4. And then if I take the limit as x approaches 2 from the right of f of x, that's Harriet. She's out enjoying her walk, la 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 la, la, and Harriet ends up where? At 2. Since these two are not equal, this says that the limit as x approaches 2, period, of f of x does not exist. Why? Because Howard's up here, Harriet's down there. Do they meet? No. They don't meet. And that's a piecewise function. That's how piecewise functions operate. That's not a normal function. It's a piecewise function. So, here we go. The limit as x approaches 2 from the left of f of x, that's Howard. And where does Howard end up? 2. The limit as x approaches 2 from the right of f of x, That's Harriet. Where does Harriet end up? 2. Since these are equal, then we can say that the limit as x approaches 2, period, of f of x equals what? 2, right? That's because even though that's a whole, for all intents and purposes, it looks like Howard and Harriet are meeting. From what we can tell, there's just a hair in between. As far as we're concerned, they're meeting. That's what we can see. From the left, from the right,